Welcome back to Honey of Knowledge. A couple of days back, I read this tweet, and to me, it was quite okay, but to someone who is not familiar with probability, it might appear quite shocking and frightening too. So, this question is, if you have a contact list in your phone and you see that there is no one infected in your contact list, it means you will say no. But if in your contact list even one person is infected, you will say yes. So this is the poll result. Around 7,500 people responded to this poll, and around 35% of them know someone in their phone contact list who is infected from COVID-19. So what does this say about the infection rate of the sample? I mean, of the contacts of these 7,500 odd people. So I decided to write a bit of Python code, and here it is. First of all, let me give you a basic background. I'm going to use random.choices from the random library. Random.choices essentially chooses elements out of a list dependent upon the weights you have provided in the function of random.choices. Now I have provided 97 and 3 to test this function. So 97 and 3 means for 97% or 9.97 probability it will take 0, and for 3% or 0.03 probability it will choose 1, and I'm making a choice of 200 such numbers. So in other words, I'll be using this list 0, 1, the sample list, to get a list of 200 numbers, and those numbers would be either 0 or 1, and the probability of choosing 0 and 1 would be 97% and 3% respectively. This is the function of random.choices in this code. Now we will not be using this fragment of code. This was just for a demonstration purpose. So now let's head to the real bit of this code. Again, I'll be importing random. I'll start from the very basics of this code. If you look at this fragment over here, what we are doing is we are providing it with a list called infection. So 0 means there is no infection, 1 means there is an infection. Number of contacts, it is 200. Now number of contacts is the number of people any given person will have in his phone. Contact list could be less than 200 or greater than 200, but I found that 200 is a good number to play with. Now infection percentage. Now this is the number which we'll be tampering with. Infection percentage is something which we are really worried about. What is the infection percentage? Because if you look at this tweet, you will feel that 35% is the infection rate, which is not true. So what is the infection rate implied by this poll? So let's just take for the time being 0.22 to see what happens if we take the infection percentage to be 0.22 or 0.22% to be more precise. Now if you take x equal to random.choices and you plug in the list here infection and give the weights as 100 minus infection percentage. So infection percentage is 0.22, it will come here, it will be 100 minus 0.22, and then k is the number of contacts. I mean, you are going to make a list of 200 people and it will be filled with 0 ones. 1 denotes the person is infected, 0 denotes the person is not infected. After we do this random.choices function, I initialize a variable infected contact with 0. Now for the length of x, I iterate over that x, and if any of the elements in the list is 1, it means that person is infected, that ith person is infected. So I will change my infected contact variable to 1, because I have reached the answer, because I need to just check even if one person is infected or not. And after I have reached that, what I will do is, if infected contact was 1, I will append to the list infected friend list. Now infected friend list was an empty list. If you check over here, I have initialized it here at the starting of the code. Now infected friend list will be appended with a yes, and it will also increase the infected friends with 1. Now you don't need infected friend list, but I have just written it for the sake of it. What we really need is infected friends. Infected friends has been initialized to 0 in the starting of the code, and whenever I get the variable infected contact to be equal to 1, it means I have at least one person in my contact list who is infected. I will increase my infected variable to 1. If my infected variable has been increased to 1, then if I print this, I'll get a 1 in this loop. If the infected contact remains to 0, then I'll append the infected friend list with a no. So infected friend list will be a list of yes, no. Now I will be doing this entire thing for poll size number of times. What is poll size? Poll size is 7,500 people. Now the poll over here has been responded by around 7,500 odd people. So that is why I'll be using 7,500 odd people as my poll size. So I'll be doing this calculation for 7,500 people. Now this is not enough for me. What I will further do is I will find out the infected friends upon poll size into 100. Now this will be giving me the percentage of people who have at least one contact in their phone contact list who are infected from the coronavirus. So this is what we are after. Now again, I will not stop at this. I will do this thing for 30 times. Now why 30? I'll be just checking the robustness of this process. If I get very similar numbers 30 times, then I'm pretty much confident that what the code is giving us is reliable. So if I run this code over here, you can see that I'm getting numbers in between 34 and 36. So if I'm getting numbers between 34 and 36, it's pretty okay for me, and I will report the infection percentage as 0.22. 35% is something which is not to be scared of, because 0.22% is quite okay with the current scenario of this disease. Now we can also change the number of contacts and infection percentage to see what's happening over here. So let us make the number of contacts to 100. If we do that, then the answer is between 18 and 20. So obviously this is not what we are expected to get. We are expected to get around 35. So changing it to 100 makes no sense. Now what if I have 100 number of contacts and I increase this thing to 0.4? If I increase this thing to 0.4, I get around 33 or 34. So this is more closer to what we should be getting at. So you can take your number of contacts to be either 100 or 200, but the infection percentage will change accordingly. So if you think number of contacts on an average is 200 for every person, then 0.22% is the infection percentage. And if you think that the number of contacts is 100 on an average basis, then infection percentage is 0.4%. This is a small video I thought of making on probability and Python because I love both of them. So I hope you would have found this useful, and now you would not get frightened by this kind of a Twitter poll. So always keep your sanity and don't get scared by any kind of news report or Twitter article or Twitter poll. Think of it logically, and you'll understand that there is no need to get frightened by big scary numbers. The reality could be much different than what it appears in those numbers. So I would like to wrap this up. Thank you for watching this video. Like this video if you found it interesting, and also don't forget to subscribe to this channel and press the bell icon. Bye bye.